In this slide, we are going to understand what a scalar can do to a vector or a complex scalar. So this is a complex number, and we are going to multiply this complex number by a complex vector b. So if b is given by this 1j minus 4, 1 minus j, so this is belong to complex 4, and beta belongs to the complex number, then we can multiply a complex number to a complex vector, and what will we get? Well, let's see. So we have the complex number here. This is I've given you in rectangular form. Of course, then you can convert into the polar form, and let's revise. So basically, we have the real part, which is 0.707, and then we have the imaginary part, which is 0.707j, and then we see that actually the length is 1, and then the angle over here is pi over 4. So what we get in polar form is the modulus is 1 and the angle is pi over 4. Now, when we are dealing with a complex number multiplying by a complex vector, we are actually dealing with complex number multiplying by complex numbers. So we always prefer to deal with this in complex exponential form because it's the easiest to, because all we are doing is multiplying the modulus and then we are adding the angle. So this is very easy. The first one is pi over 4 plus 0 is pi over 4 for the angle. The modulus is 1. So the second modulus is also 1, but the angle is pi over 4 plus pi over 2, then we get 3/4 pi. Pi over the third one is pi over 4 plus pi, then we get 5 pi over 4, and then the last one is 1.5 pi plus pi over 4, we get this. So it is important to show you what is beta times b. This is the first element of beta times b. So this is z0, z1, z2, and z3 of belonging to beta times b. They are still sitting on the unit circle, but they are basically all phase shifted by pi over 4. And where is the pi over 4 from? It comes from the beta. So the entire sequence is a phase shifted version of b. That's all, right? And now we again plot in 3D, and we again plot in real n versus imaginary, and you can appreciate. But maybe the way to appreciate this beta times b is in this form. It is to compare the original 2D. Let's see. This is the original 2D here. These 4 numbers sitting on these 4 places, and they are going to be rotated anti-clockwise. So now the 4 numbers are here, and the scalar multiplication, because the modulus is 1, so the magnitude didn't change, but the angle has allowed every of these points to be added by pi over 4. So your interpretation now of beta times b is very clear. We change the original vector b by some modulus of beta as well as some angle of beta. Okay, that's it. Thank you. And this will be very useful as we explore DFT later on. Thank you.